All right, today we're talking about polygons. A polygon is a simple closed figure formed by 3 or more line segments, all right, which are called sides. All right, so that's what a polygon is. Today, some of your homework is going to ask you, is this a polygon or not? Okay, you need to write this down. All right, now this is the names of certain polygons. Okay, triangle, quadrilateral, pentagon, hexagon, heptagon, octagon. Those are the common ones. Okay, there's 2 more that I left off. You can look them on page 617 in your book. 9 sides is called nonagon. 10 sides is decagon. All right. Now anything after that, okay, those aren't near as common. You don't see those. All right. You see hexagon a lot. You see pentagon a lot. Okay, those are common shapes. Triangle. Okay, that's why they have common names. If they're not common, like something with 21 sides, right? Do you know what that's called? No, you don't see it very often. So instead what they do is they just write the number out in front, 21, and put gon behind it. Okay? It's a 21-agon. Okay? Or 22-agon or 15-agon. Okay? Now octagon, you could also call it, is 8-gon. Okay? But since you see an octagon all the time, right, they have a common name for it. All right. Now, here's what your homework is going to look like. Okay, a couple of questions. Okay, is this a polygon? If it is, then you're going to classify it. If it's not, then explain. So draw these figures, okay, and then we're going to identify and classify. This first one, is it a polygon? Is it a simple closed figure? Yes, it is. Okay. If it is, then you're supposed to classify it. How many sides does this have? 7, so we call this a heptagon. The next image, this one, is this a simple closed figure?
Yes.
It's not a simple figure. It is no, because the sides overlap. Okay, polygons, right? The sides don't overlap. So you're supposed to explain, so make sure you're right. The sides overlap. If you just write no, I will count wrong tomorrow. Yes, Mackenzie.
What if you can't explain it? Like you don't know which one, but you can tell us that, right?
There's got to be one. Let's look at this one. Okay, is this a polygon?
No.
No, Mackenzie. Why is this a no? Okay, because it's not closed. Right there, you go. If it's not a polygon, it should be pretty obvious why. Okay, you should be able to find a way to explain it. Okay. Any questions on how to identify and classify polygons? All right. Here's something else about polygons. The sum of the degree measures of the interior angles of a polygon, okay, is this formula: n minus 2 times 180. Okay, like this says, the sum of the degree measures, okay, you can use this formula. Someone raise their hand and tell me what they think n stands for in this formula. We're going to find the degree measures of a polygon. What would I plug in for n? How many sides? N is the number of sides. Good, Emery. Okay. Now, this is a formula. Okay. If someone was able to come up with it, then it's probably true. But we can check it. Check it with things you know just to make sure. Okay. Do I know what the interior angles of a triangle add up to? What does a triangle add up to? 180, right? So can I plug 3 into this and see if it equals 180? What's 3 minus 2? 1. What's 1 times 180? 180. So it's right for a triangle, right? Let's check a quadrilateral. What does a quadrilateral add up to?
4.
No, it has 4 angles, yes. But was it, remember from last week?
360.
360. So let's see if it's right. What is 4 minus 2? 2. What's 2 times 180? 360. So if it's right for a triangle, and it's right for a quadrilateral, then it must be right for all the rest, right? Okay. Find the sum of measures for a nonagon. Okay, as we discussed, a nonagon has 9 sides. So I'm going to take 9 minus 2 times it by 180. 7 times 180 is 1260 degrees. So a nonagon has 1260 degrees inside. Easy enough, right? Okay, let's find the measures of a 14gon. So just write 14gon above, right? So we do 14 minus 2, because the number of sides, there's 14 sides in a 14gon, times it by 180. So 12 times 180 is 2160 degrees. Easy enough, right? Now, okay, this is identify the polygon given the sums of the interior angle measure. So it's backwards. They give you the angle measure, right? They give you the sum of the angle measures. You got to find out what polygon it is. Okay? So write down all of this, and then we're going to work it. So I know the sum is 720. So I know to get the sum, I take n minus 2, the number of sides is minus 2, times 180, don't I? So 720 is like my answer, what we were finding earlier. Okay, now we're just going backwards. So the first thing I do is divide by 180. 720 divided by 180 is 4. 4 equals n minus 2. So Blaine, what do I do now?
You add 2?
Add 2 to both sides. Okay. N equals what, Emery? 6. What polygon has 6 sides? Blaine?
A heptagon.
Hexagon. There's my answer. Alright, let's do 1980 degrees. Equals n minus 2 times 180. Pyle, what do I do first?
Put the 180.
We divide by 180 to both sides. 1980 divided by 180 is 11. Mrs. Moles, what do I do now?
You minus, no, add 2.
Add 2 to both sides. Okay, what is 11 plus 2?
13.
13. Okay, do we know what the common name for a...
Nope.
Okay, we don't, so I'm just going to call it 13gon. Easy enough. Okay, let's do one more. 4140 equals n minus 2 times 180. Divide by 180. 4140 divided by 180 is 23. So we add 2. Riley, what do we call this? What kind of polygon is this? It has 25 sides. Yeah? 25 gone, good. Any questions? Alright. Now it gives us what is one of the angles. Okay, we need to find one of the angles. So what we do, alright, is we find what the sum is for a heptagon first. Just like we've been doing. How many sides does a heptagon have? 7. So we do 7 minus 2 times 180. 5 times 180. 900. Now I need to find one of these angles. How many angles does a heptagon have? 7, right? It has 7 sides. It's probably going to have 7 angles, right? Think about a triangle. How many sides does a triangle have? 3. How many angles does a triangle have? 3. So what I'm going to do is I'm going to take 900 divided by 7. Okay? We get this. 128.57. We're going to round to 6 degrees. So if this is a normal heptagon, which just means all the angles are equal, then they add up to 128.6 each. Okay? Alright. Right pentagon. How many sides does a pentagon have? 5. So 5 minus 2 times 180. 3 times 180 is 520. Or 540, sorry. Someone tell me what we're going to do now, Nikki. Divide by what? 5. 540 divided by 5. Every angle in a normal pentagon should be 108 degrees. Okay. Here's your homework.